My name's Ben Jarvis. I'm head of technology at Adatus, and today I'll be talking about how you can architect your data platform for success. And I'll be doing that by giving 10 top tips based on the experiences I've had implementing data platforms for our clients at Adatus. So why do we need this session? So starting from scratch in the cloud is really difficult, and building data platforms and architecting them is really difficult as well. So there's lots of different ways to implement them. There's lots of different components to choose from. And there's lots of ways that things can go wrong when we're mixing those components together. And with that, there's lots of new and quite challenging technology that we need to learn to implement a platform. And this makes it quite a complex undertaking. So one analogy that I like to use is that building a data platform is kind of like trying to build Lego. So we've got lots of blocks that are of different shapes and sizes, and we can put those together in many different ways. And rather than building a simple little model tractor like we've got on the screen here, we want to build something like this Bugatti Veyron that we've got here, which looks cool, can do lots of different things, and drives really fast. So when we're looking at Azure services, they're similar to those Lego blocks. So each of them has different characteristics, and we can put them all together in many different ways. And what we want to end up with as architects is we want to combine those together and create an architecture that's both fit for purpose and can deliver on both our current and future requirements. So hopefully the 10 top tips that I'll give in this session will give you a starter for 10 on achieving that in your own environment. So the first tip is to start with a strong foundation. So Azure is a complex beast, and we need to set it up in the right way to ensure that it's going to work for our requirements and ensure it can cope for our current requirements, but also our future requirements. And this includes things like getting networking set up, but also making sure we've got a tagging policy so we can track costs, and then making sure that we've got the correct policies applied and the correct safeguards in place to ensure that the environment we're provisioning is secure and compliant. And Microsoft has lots of really good guidance around this. So there's something called the Cloud Adoption Framework, which is linked on the screen. And that's basically a 7-step process to get Azure deployed in your environment. Something else that Microsoft provides is the enterprise scale landing zone. And this is something that we tend to deploy to most of our clients where they're just starting out in Azure. And basically what that gives you is a set of predefined bicep or Terraform templates to kind of set up that basic configuration in Azure. So that includes guidelines for identity, so that's managing your Active Directory and all of the components within it, but also networking, so spinning up the right network structure, making sure you've got VNets and connectivity with your on-prem systems in place, and then also ensuring that your subscriptions are structured in the right way and you've got the right kind of management group set up to align with your organizational structure. So Microsoft provides that guidance, and that's all out-of-the-box open source functionality that we can use to get our solution deployed. So the next tip is to consider the non-functional requirements, or NFRs. And NFRs are one of the big things that will change the overall architecture of the solution. So these cover things from security through to scalability and cost optimization. And some of the kind of key things that will affect the components we deploy, but also how we deploy them, are things like security. So do we need private endpoints, or do we just need public endpoints? So that will influence how we design our network in Azure and how we set up things like DNS. There's also cost optimization. So do we need to design a solution that's low cost, or can we use some more expensive components that will increase the productivity of our developers? So again, that will influence what kind of components we're choosing to make up that platform. Then there's performance. So do we need a solution that's going to run once daily and refresh a data warehouse? Or do we need a solution that's going to be streaming data in real time? Again, that's going to affect which services we choose to deploy. And then finally, there's availability and recovery. So do we need to spread our solution across multiple Azure regions for fault tolerance? Or do we need some separate backups over and above what Microsoft gives us out of the box in Azure? So again, that's going to affect what kind of components we need to deploy, but also how we actually go about configuring them and the effort required to configure them. So it's important to make these decisions upfront before you actually go to deploy the platform. Again, on this, Microsoft has some good material in what's called the well-architected framework. And this basically provides some good pointers on the kinds of questions that you need to be asking when you're defining those non-functional requirements, but also how you go about meeting them using those Azure components. And it covers areas like cost optimization and performance and security. And some of the guidance is aligned to some of those specific services that we're using in Azure, such as Synapse. So it's a really good starting point when you're starting to define those requirements. So the next tip is to build with the future in mind. So data platforms can enable lots of different capabilities in the business. So you've got data warehousing, but you've also got data science and things like IoT. And when we're starting a platform implementation, it's worth considering what capabilities we might want now, but also further down the line, so that we don't shoehorn ourselves into an architecture that doesn't fit with those capabilities. And people will take different routes as they're implementing a platform and have a different journey. So some might start with data warehousing and then move on to data science and maybe some IoT, where others might start with data science and then move somewhere else after that. So if we have a rough idea of the kind of path that we're going to take, then we can make sure that we've got the right components in place to enable that later on. So one of the key decisions as part of this is whether we build a data warehouse or a data lakehouse. And building a data warehouse might meet the requirements that we've got right now. So if we're wanting to give the business some reporting and kind of build out some basic analytics. But if we've got the requirement to do something like data science or IoT further down the line, then we might be better off going with a data lakehouse type architecture to give us that flexibility. And it's also worth considering how the platform might be maintained going forwards. So if there's going to be multiple distributed teams that are maintaining and developing the platform, then architectures such as data mesh are worth considering. And data mesh is kind of one of the big buzzwords that's out there at the moment, and I kind of don't think everybody should jump wholesale into adopting it as a pattern. But something, again, that Microsoft have created is the cloud scale analytics patterns, and they form part of the cloud adoption framework. And these are a really good take on patterns such as data mesh, but also data fabric. And they give you a good way to start small and then grow over time. So we've deployed this to customers where they're starting with a single team maintaining the platform, but then they want to grow that out over multiple countries or multiple business areas over time. And this architecture gives them the flexibility to do that. And it's a good way to future-proof the platform. So the next tip is to define standard patterns. So there's lots of mundane and quite manual tasks as part of building a data platform. So these are things like ingestion, but also orchestration, and then populating our target data model. So they take lots of time, and they're quite repetitive, and we have to write the same code over and over again. So what we can do is look to automate these processes and standardize them so that we can increase our productivity and make sure that we're delivering a consistent platform with lots of reusable patterns. So in the case of ingestion and orchestration, there's standard metadata-driven patterns that we can use within Data Factory. And for populating our data model, we can look at using code generation or some of the automation tools that are out there to create some of that boilerplate code for us, so we're not constantly repeating that process and copying and pasting code every time we look to build out an object within the platform. So there's some off-the-shelf frameworks that can give you this capability. So Databricks has Delta Live tables, and that's an ETL framework that provides end-to-end orchestration, but also gives you the capability to handle things like slowly changing dimensions. There's some third-party tools from the likes of Warescape, and they're really big on kind of data warehouse automation and providing those standardized patterns. And then there's also some open source frameworks out there. So a framework I've come across for Spark is YETL, And that basically gives you, again, a standard way to build out those kind of data warehousing patterns within Spark. At Adatis, we've got our own framework, which we deploy to our customers. And this has metadata-driven patterns built in and has all of those standard kind of bits of automation built in to give a starting point when you're building a platform. And this aligns with a lot of the Microsoft guidance that we've been talking about. So things like cloud scale analytics is all baked into it by default. And that just gives kind of a head start when you're actually building out a platform. So automation is another key area that can help ensure that your platform is reliable and delivers consistent results. So if we think about the code, build, test, deploy loop, we can automate that using different tools. So on the coding side, we want to automate as much of our development process as possible. So we can do that using tools like Visual Studio and Visual Studio Code. And we can use tools like PowerShell to do things like code generation to kind of automate the creation of some of that more mundane kind of boilerplate code. Then on the actual building side of our code, so when we want to compile it and prepare it for deployment, we can use tools like Azure pipelines to automate the CI process. And then on the testing side, we want to have an automated set of regression tests that we can use to prove that our platform is working as expected before we actually go ahead and deploy it. And to do this, we can use tools such as PyTest, if we're using Python, or there's more data quality focused tools like Great Expectations out there, which are designed so that you can assert that your data is of a particular format and contains particular values. And that's quite a good way of kind of testing that your platform is working as expected, but also building in some of that data quality testing by default. And again, we can run all of that process using Azure pipelines. And then finally, there's the release process. So we can automate that using Azure pipelines, so we can automate the continuous deployment process. And there's tools out there such as Azure Bicep or Terraform to automate the deployment of our infrastructure. And that just makes that release process nice and repeatable and easy to manage. So if we can implement that automation, then that will basically decrease our cycle time. So it means we can deliver value to the business quickly, but also in a repeatable way. So we're consistent with our deployments, and when we're deploying to production, we know that the solution is going to work. So the next tip is making sure we've got the right skills in place. So when we're building a platform, we need lots of different skill sets. So we need data engineers, but also data scientists, and people to actually go ahead and develop our reports, and then people who will actually be using the reports. And each of those needs different skills to do their jobs, and they need different training to actually learn those skills. So it's essential that we've got a plan in place to provide them with that training and make sure that they're skilled up before we deploy our platform. So again, Microsoft has some really good certification paths that are pitched at different levels. And these cover areas from infrastructure and DevOps through to hands-on data engineering and hands-on data analysis. And they give a really good place to start, but they don't always provide you with all of the knowledge you need to actually implement a solution. So there's lots of other great content out there on the likes of Microsoft Learn, but also training sites like Pluralsight, which can kind of extend your knowledge above what the certification will give you. So at Adatis, we've got a set of certification paths, and they will align to the different roles required and include lots of training from Microsoft, but also other sources. So the next step is to define the use case that we want to focus on. So we want to pick an area that is targeted to a specific business area or process and going to deliver some kind of tangible benefit that we can use to refine the technology, but also prove the value of the platform. And to do this, we should look to implement a minimum viable product. Now, just in the interest of time, I'll skip over this slide. But this just gives you an idea of some of the kinds of processes that we can look at when we're looking to identify a minimum viable product. So it's things like legacy processes that are causing lots of kind of headache for people in the business, but also looking at processes that can transform the business and allow them to work in a new way. And what we want is something that's quite simple and quite isolated and can be our kind of first target for implementing a solution in the platform. The next tip is to get hands-on with the technology. So whether you're an architect or you're a developer, it's really good to get hands-on with some of the tech that we're working with. It's a good way to learn, but also to determine what the best approach is to implementing things, and also to optimize that delivery process. So we're doing things in the simplest and most effective way possible. So once the build has started, it's important that we keep testing and learning. So as we've discussed before, we're building out lots of automation processes, and that means that we can deliver our solution to production really quickly and get it into the hands of the business users really quickly. So that means that throughout the process, we can be testing what the solutions we're building, putting them into the hands of the business, and then learning from their feedback and incorporating that into the solution. And building a platform is kind of like an iceberg. So the bit that we're actually delivering to the business is the small bit that's above the water. So that's our reports or our kind of outputs from data science models. And then all of the platform work that happens below that is kind of the bit that sits below the water. And that is the bulk of the work. So like in most implementations, that's kind of 80 to 90% of the work. And that's where you're kind of spending the bulk of your time. So from the business point of view, it's quite difficult for them to see the value in all of that platform work. So the sooner you can get something into their hands and get them to start testing it, the better, really. And along the way, you're going to make mistakes. So you won't get things right the first time, and the business might not be pleased with the initial outputs. But the benefit of working in this way and having that short cycle time is that we can refine and improve really quickly. So the final tip is once it's time to push something into production, it's important to think about the ops in DevOps. So most people are really good at the CI/CD side of DevOps and really good at automating their development processes. But then the actual support and monitoring of the solution becomes an afterthought. So it's important to make sure you've got the right monitoring processes in place. So when something goes wrong, we've got a process in place to pick up the pieces. So Azure has the Azure Monitor Stack, and this includes components like log analytics. And this gives you a really good way to start collecting data from all of your services, but then also building some alerts and visualizations on top of it so that we can tell somebody when something goes wrong and get them to go ahead and fix it. And this allows you to kind of improve the reliability of the platform over time and build out alerts as we hit problems. So some of the kind of essential areas that we should monitor are things like pipeline failures, but also data quality issues, and then things like unusual data volumes or unusual runtimes, as well as things like data freshness, so making sure we're getting fresh data through from our source systems, and then things like security, so making sure we're monitoring failed logins and other security alerts that might cause a problem with the platform. So that's all for the session today. It was quite a short time and lots to cover, but I hope you found some of it useful. If you're interested in learning more about what a Datis can offer, then come down and visit us on our stand. We're really happy to talk about the framework or any of the other services that we offer. And finally, I think we've run out of time, so there might not be time for any questions, but feel free to grab me after the session. I've also included our website address and my email address if you want to get any more details. But thanks for listening.